So the first problem I'm going to do is going to be a graphing problem, and in order to do this problem I'm going to have to put both of these into slope-intercept form, so I'm going to solve for y in both of them. So in this one I'm going to leave y where it is. I'll subtract x from both sides. So then I get negative y equals negative x minus 9. Now I don't want negative y, I want positive y, so I'm just going to divide both sides by negative 1. And I get y equals x over 1 plus negative 9 divided by 1. It's just 9. Well, I don't need to write x over 1. I can just write x plus 9. And I'm going to graph this one. I know that the slope is 1. So my change in y over change in x is just 1, or 1 over 1. And I'm going to start at 9 as my y-intercept. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Slope is 1, so I go over 1 and up 1. But since I ran out of room, I can also go down 1 and to the left a few times. I'm going to draw my line through those. So that's my first one. Now my second one. Still going to solve for y. So I'm going to do that by first subtracting 3x from both sides. So I'm going to get negative 3x equals 8. Then I'm going to divide both sides by 4 to get rid of that 4 with a y. Then I'm going to divide each term by 4. So I'm going to get negative 3 over 4x. And then I'm going to have, oh, should be a plus. Then I'm going to have 8 divided by 4, which is 2. So that means I'm going to start at 2, and I'm going to go down 3. My change in y is 3, and to the right 4. So start at 2, down 3, 1, 2, 3, right 4, 1, 2, 3, 4. Could also go up 3, 1, 2, 3, and to the left 4, 1, 2, 3, 4. I usually go until I see where it's going to cross that other line, and then get your ruler or something straight to draw your line through that. And then the solution, the one that where you go and write your answer over here, is where they cross. So these cross at 1, 2, 3, 4. So negative 4 and 1, 2, 3, 4, 5, up 5. So that's your solution, is where they cross. For the next one, it's substitution. So you want to substitute one of the equations into the other one. This is good when you see a variable that's by itself, like this y has nothing else with it. So I'm actually going to get that y by itself in this equation by subtracting 3x. I'm going to get y equals negative 3x plus 8. And now, since I used my second equation to get that equation, these are my two equations. And so here I see that y is equal to that stuff. So I'm going to go into my other equation, and instead of y, I'm going to replace it with all of that stuff. So we get 2x minus 7 times negative 3x plus 8, all in parentheses, and then equals 13. So all I did is replace that y with all of that stuff. So next step is to get that x by itself. So I'm going to simplify this side, distribute. So I've got 7 times 3, which is plus 21x. And then I have 7 times 8, and that one's negative. So negative 49, 50, 51, 52, 45, 6, 56, right? Okay. Alright, so now I need to combine my like terms here. I'm going to get 23x, because I've got those 2x there, minus 56 equals 13. And then now my goal is just to get x by itself. So I'm going to first get rid of the 56 by adding 56 to both sides. Okay, so then I'm going to get 23x left over here and 69 here when I add. Last thing to do is divide both sides by 23. I'm running out of room, so I'm going to go over here. X is going to be equal to 69 divided by 23 is 3. So that means x is 3, but I don't know what y is. So I need to go back into one of my equations and substitute in the x value. So I'll use the second one. Just going to substitute this x value here. So then I get 9 plus y equals 8, so get y by itself. So y is -1, and x is 3, so you write your answer as an ordered pair, you write 3, -1. Now for the very last one, it's elimination. This problem is actually a little bit easier, so I'm going to do number 6, and you can try the easier one. What you do here is you try to make it so that when you add the two equations together, one of the variables is eliminated. So before you start, make sure that all of your x's are on the same side in both equations, y on the same side, and the number on the same side. Then if you just add them, you're allowed to just add them together, but you want to do it so that they add to 0 or one of the variables is eliminated. So if we go ahead and add right now, you notice that x would still be there. We'd get 11 x's, and here if you add those together you get 10 y's, so that's not helpful. And then even if we made it like that one negative, still you would end up with -5x and 6x, and you'd get 1x. It's not 0. We want 0. So then you want to try to find a number that you can multiply each, like the entire equation by, to get the opposite of one of the other. So for example, I want to see maybe if there's a number I can multiply by 3 to get -7, and then when I add them together they will eliminate. But actually the way this problem works is there isn't a number that I can, not a whole number that I can do that with. So instead I have to change both equations. So what I'm actually going to do is I'm going to focus on getting rid of x, and I am going to multiply this entire equation by something and multiply this entire equation by something so that both x's will add to 0. So one thing I usually do is just use the coefficient of the other one. So like I would make that -6, multiply this whole thing by -6, multiply this whole thing by 5. There are other numbers you could use, but that's one way you could do it. So here we get -6 times 5, which is -30x, and you multiply it by everything. So then you've got -18y equals, let's see, 26 times 6 is 156, so -156. And then you're going to multiply this whole thing by 5, so you'll get 30x plus 37y, and then 21 times 5 is 105. So now what you do is actually add your equations together, and the reason we do that is because now if you see x actually adds to 0, and that's what we wanted to do, so that adds to 0. And then you've got 37y and then -18y, so it's 37 minus 18, which is 19y. And then here you would get -51. Okay, so then what you want to do is you want to get y by itself by dividing both sides by 19. So let's see here. When I do that, let's see, when I do that I get a decimal, which makes me wonder if I did something wrong here. So let's look back at this. So that would be 30, and that would be negative. And then I'll do that again, 26 times 6. And then here's 30. Oh, that's not 37, is it? That's 35. Sorry, that's where my mistake at. So that should have been 35y. And that's still 105. Okay. 17y. Okay, so then y is -3. Sorry about that, got a little mistake there. So it's okay to get decimals sometimes, but usually in the problems they give you, they're not going to have you do a decimal because it would just be more complicated, to be honest with you. So that's kind of how I knew I probably made a mistake. Alright, so I got y is -3, so I'm going to go back over here and I'm going to replace one of my y values with -3. It doesn't matter, it could be this one. So we're going to do 6x plus 7 times -3 equals 21. 6x, and then we're going to do 7 times -3, -21 equals 21. So add 21 to both sides, starting to get x by itself. So 6 equals 42, and then what you would do there is you would divide both sides by 6 to get x by itself. So you get that x is 7. So when you write it as an ordered pair, you would write 7, -3.